Hi, and welcome to my talk about monitoring of CloudStack and components. Maybe at first some facts about me. My name is Alexander Stock. I'm working as a cloud infrastructure architect at Intelligence. And over the years, I've collected some experience with VMware, KVM, Nagios, and of course with CloudStack. So I'm working with CloudStack since around about 2015. I think this was version 4.6, which was current there. Some side facts about our company. We are hosting also some events in the area of Dresden and Berlin for CloudStack, Ansible, and Ceph. And if you want to contact me after the presentation, there's my business mail address. So if you have questions afterwards, you can contact me. Some facts about our company. So we were founded in 1989 in Germany. We have now about 7,900 employees around the globe. So we have 25 offices in 25 countries around the world. For example, in the US, in Canada, of course in Germany, and also in many countries in Asia. Our main business is the development, the consulting, and the support for SAP solutions for our customers. And we currently have around about 6,000 customers which we deliver services to. Okay, what do I want to show you today? I want to give you an introduction of what we use for monitoring of our landscape and especially CloudStack. And of course, I will show you some insights. How do we monitor our management server components like MySQL, Tomcat, and also the CloudStack API itself. The next part will be about distributed monitoring. So we have a distributed monitoring setup for our customers. And the last part will be about monitoring virtual routers in our environment, which is also based on the distributed monitoring setup. Okay. But first I want to give you a short introduction of what is our cloud about. So, of course, we use CloudStack as the heart and orchestrator of our cloud system. So we have an advanced networking setup with Ceph as our storage backend, with KVM as the hypervisor. And the main purpose of our cloud is to deliver automated application setups, especially for SAP systems like HANA, S4, and also R3 systems. For this automation, we use Ansible, so for all our tasks, for infrastructure setup, and also for the application setups. And we have a self-written portal which abstracts away all the APIs and tools we use in our landscape to give the user a unique experience with one portal where he can trigger his actions and install his systems. So that means the customers don't have direct CloudStack access in our landscape. So why do we monitor CloudStack? We wanted to identify and detect performance issues. We want to detect misconfigurations, also resource bottlenecks for the customer, for example. And we want to get a long-time overview of our installations and all the surrounding components of CloudStack. And also the status in detail of our virtual routers and of the system VMs. What do we use for monitoring? We use CheckMK. CheckMK is a Nagios-based monitoring solution which ships with a nice UI you can also see on the right side, where you can have a complete overview of what's going on inside your landscape and also in the customer landscapes. With this UI, you can also manage your hosts and services and also create rules for thresholds and settings for your monitoring system. It combines the advantages of passive and active checks in the Nagios world. And it has also some auto-inventory functions. For example, when you add new storage to a VM or a new network interface, it will be automatically detected and added to your monitoring system. It has also scale-out features. So we have a master-slave setup here. And this is based on a so-called live status. It's a Nagios core module which enables you to read data directly from the Nagios core without any file system in between. So it's very resource friendly and fast. It also ships with a high amount of predefined plugins, which you can use, for example, for Windows, for Linux, and also for storage boxes like EMC, NetApp. And you can also monitor network devices out of the box, Cisco F5 devices via SNMP or via predefined APIs. The next thing is a big picture of the architecture of CheckMK. So in the middle you can see the Nagios core, which has below and on top the live status interface, which acts as the unique data source for the surrounding tools in the CheckMK ecosystem. That means the multi-site web platform uses live status as a data source, and also Nagios, for example, and the underlying checks for CheckMK, also using the live status interface. With the plugin called also CheckMK, which is shipped with the system, you can monitor your host via pure TCP connection, via SSH, and also SNMP for some special devices like routers, firewalls, and storage boxes, for example. You can also use your legacy Nagios checks, which you have used maybe before with your old setup, and can continue using your own code here. How does CheckMK collect data from the hosts? So at first you have the Nagios core, of course, which triggers an active check which calls the CheckMK plugin. This plugin will then connect to the target host we have configured and will start the agent on that host. So it's in most cases just the PowerShell script or a bash script on Linux. And the script will then collect the raw data of the host. That means we just collect the metrics like the fill rate of a file system or the statistics of a network device, and will send back this data bundle to the CheckMK host, especially to the plugin, which then will start to compute the results for the checks for each of the metrics, and will send these will send the results back as passive checks to the Nagios core. Also, the RRD files will be written. This is the format or the standard Nagios format for long-term data, where you can get a long-term overview of your installations. And this setup is very resource friendly, so you just need one TCP connection to gather all the data of a host at once. So it's very resource friendly also from the network perspective. And this is the way CheckMK collects data from all the hosts. So let's take a look at the core components of the management server. So the first one here is the MySQL server, which CloudStack relies on. And also CheckMK has a predefined plugin for this here, so you don't have to download from third-party tools or something. The installation is quite simple. You just have to download the plugin to a specific folder. You have to create a user, which just has select rights on the database, and you have to specify a config file where you give in the user and password of that specific user. Then the auto inventory function of CheckMK kicks in, and with the next inventory run you will see checks for every database you have configured on your database host, for example the cloud and the cloud usage database. And you will also get checks for connection states, for slave status when you have a replicated setup of your MySQL database. You have InnoDB I/O checks, which detects the I/O throughput of your database engine. And this is all automatically detected via the CheckMK functionality. So you have a quite good overview on also for the long-term data. You can see on the right. So you can monitor your database quite well. The next core component of CloudStack is, of course, the Tomcat server. Here, CheckMK also provides a predefined plugin, which is based on Jolokia. So what is Jolokia? It's some kind of Tomcat extension. This is some kind of WAR file you have to add to your Tomcat installation, which builds up an HTTP bridge within which you can query data from the internals of Tomcat. That means you can get some statistics of the Tomcat server, how many connections it has to handle at the moment, and yeah, also the current sessions for a specific URL. Question?
How did you zero in on Jolokia rather than JMX or something? What would be the advantages?
It's the standard way CheckMK does it. So it's the predefined way to go for that system. But if you want to go with JMX or something, you also can define your own plugins and do it that way. That should be no problem. So the installation is quite similar to the MySQL check. You just have to download the Jolokia WAR file, the plugin, and then use the auto inventory function on the management host to get the checks into your monitoring system. That means you will get the request and session checks for every URL which is hosted on the Tomcat service. You will get checks for scavenge, mark sweep, so for garbage collection. You will get the memory usage of the JVM processes, and also you have some thread pool checks automatically detected. Of course, you have, again, the long-term data, so you can get an overview of maybe also the last month or the last weeks. This was about the two core components CloudStack uses from a server perspective. And we decided after this was finished that we need also some overview of what's going on inside CloudStack. So we decided to develop a plugin to monitor specific parts of the CloudStack API to get an overview of what's going on inside CloudStack. For example, the connection status of a hypervisor, the current status of virtual routers, and also some capacity checks, for example, to get an overview of what is globally consumed in our installation. It's a Python-based plugin. You can download also on GitHub. So when you want to give it a try, you can download it there. And it's also usable for plain Nagios installations as a simple active check if you want that. Okay, let's take a look at the checks we have defined now. So the first three checks are more of a status checks of objects defined in CloudStack. That means, for example, the first one is the host status check, which gathers the list of configured hypervisors from the CloudStack installation and checks if the host is enabled, if it's have an alert state, or if it's maybe down and not reachable from the CloudStack management host. The same for the system VM. Here we also check for alert states and for maybe a system VM which is down and needs to be rebooted or to be replaced by a new one. The last one is the virtual router check, which gathers the list of virtual routers of your CloudStack installation and checks also if the routers are up and running and also if they need an upgrade after your CloudStack update, maybe from 4.11 to 4.12. And if you use redundant VPC setups, it also checks if there is an active and a backup node for your VPC setup. And informs you, of course, when one of the nodes fails and gets in a critical state and sends you a mail. The next three checks are capacity-based checks. Question?
How does it do the discovery versus the database connection?
Sorry?
How does it do that discovery?
It's all via the CloudStack API.
Oh.
Yeah.
VRs as well?
Sorry?
Virtual routers as well?
Yeah, sure. Every check is API based, so we don't access the CloudStack database directly. The next three checks are capacity checks. So the first one is the standard capacity check, which gathers the global resources you have or you can use in your cloud. So it's the same data you see when you log into CloudStack and see the landing page with the overview of the resources. This is the data we collect here. You also can define thresholds for that, so you can be informed maybe when you have used 80% of your VLANs in your zone. We can do the same thing for domain and projects. So we can also check the resources consumed already by a specific domain or by a specific project. And we also can define thresholds here so that we can be informed when a customer reaches a specific level of resource consumption. The last one is the offering check, which reads all the defined offerings from CloudStack and simulates the deployment on all the configured hypervisors and counts the possible deployments of a specific offering. Also here we can define thresholds to be informed maybe when we just have one XXL offering left for the customer, so that we can order new hardware or maybe delete some test VMs or something. So, and also the capacity checks will make use of the auto inventory function of CloudStack. So that means when you add a new offering, a new domain, or a new project, it will be automatically added to the monitoring configuration. So you don't have to specify it with each customer you add to a CloudStack system. How do we define the thresholds for these checks? So it's all included in the UI and the API of the CheckMK monitoring system. So at the first picture, you can see the thresholds for CloudStack global resources. So that means you can set warning and critical levels for that specific metrics. Like, for example, here, the VLAN resource usage we set to a warn level of 60% and a critical level of 90%. In the middle, you can see the usage for domains. Here's the specialty. You can set also some default values for new domains, which will be added to CloudStack. So you can define default thresholds, and you can also define custom thresholds for specific domains or projects when you want to be informed for special customers when they have reached some limit. The last picture is for the offerings. So you can also define for specific thresholds for specific offerings. So for example, here we want to be informed when we want to receive a warning message when we have reached 5 deployments of our XXL offering, and we want to receive a critical mail if we reached the threshold of 1 deployable XXL offering. It was about the monitoring of the CloudStack components itself, and we have also some managed service where we offer monitoring for the customer systems, and for this we also need some distributed monitoring to spread the load over several monitoring servers. And so as I said at the beginning, CheckMK offers the possibility to build up a master-slave construct with several slave servers where you can distribute the load of your monitoring instances to. So you have one master node which holds all the configuration for the hosts and for the services of the customers, and it distributes all the changes you made to that hosts via API to the slave host you configure for the customer, for example. So the slave hosts are also pure CheckMK hosts with an own Nagios core, which hold their data locally. So there's no data transport back to the master. For example, when a new state of a host occurs, like maybe from Zabbix. So that makes it really resource efficient because there's no transport back to the master. And the data will just be queried on demand when you as an administrator start a query for a specific customer. Also, the slave servers can be used as an API and as a UI for the customer. So when he logs into a slave host, then he just sees his hosts and not from customer B or C. How does that look in our environment? So as I said at the beginning, we have an advanced setup in our CloudStack environment. So that means we have a fully fenced networks for our customers with a router in front, and several VMs in the customer network. And in every network we deploy a so-called orchestration virtual machine, which offers some services for the customer in this specific network. For example, for central authentication, for backup, for the automation, of course, and for CheckMK slave host. the orchestration VM also has a second interface in a service network, where also the master node is resided in, and also our T-Cloud portal, which is the single point of administration for our customer. And the same way the master VM receives the data via live status from the slave hosts, we do it with the portal. So we just query the specific Arch VM of the customer and receive the status of a specific host or a specific service of that host. And we can display it later in the portal to give the customer a complete overview of what's going on inside this VM. How does that look like? So this is a screenshot of our portal and the virtual machine main view, where we can find many informations about the virtual machine. So for example, IP configuration, some cost information, and also the attached volumes and firewall rules. And we have also a tab for monitoring, which reflects the monitoring status on that Arch VM or on the orchestration VM, and so that the customer can see directly what's wrong with this virtual machine and where we may have to take action. We also offer some combined overview at the landscape level. That means the customer can also see all the warning and critical information of all the VMs resided in that specific customer network. So we have everything on one view, what's currently wrong in that landscape. Okay, now we come to the last point, which is the topic virtual router monitoring. So at some point we decided to monitor also our virtual routers or include it in our monitoring system. And we needed to find a way how to install our monitoring agent on the virtual routers of the customer, and how to get the data from the virtual router. So the picture is maybe a little bit complicated, so I try to explain it. So on the right side you can see your CloudStack instance and also your our CheckMK server. And on the CheckMK server, periodically there's a synchronization script running, which gets all the data, all the virtual routers from CloudStack and compares it with the virtual routers already configured in our monitoring system and identifies which routers are new. And with this information, we identify on which hypervisor the virtual router is running and use the hypervisor management interface as an SSH proxy interface to configure the virtual router. So we use the link local interface because we use KVM. We have no direct connection to the management interface with KVM. We use this as a proxy for the link local interface, and we install on that way our our monitoring agent and also the plugins we need for the virtual router. After this has happened, we add the host to the CheckMK configuration, and CheckMK configuration will be replicated to the specific customer slave server. So the slave server you see down here, the virtual appliance, this would be the Arch virtual machine, can then monitor the virtual router over the guest network and collect data like on any other Linux or Windows host. So we have it just added to that specific monitoring configuration. Questions to that? No. What was the result of this project? So currently we have all virtual routers inside our monitoring configuration, spread it all over the slave servers of the customers. So we have no load problems with central components here. We also automatically delete virtual routers when the customer project gets deleted from CloudStack. And we already identified some problems here. So we have some packet loss on several interfaces, which we currently investigate what's the problem here. And we wouldn't have seen that without integrating the virtual routers in our central monitoring. Okay, now a short outlook of maybe what to come in the future. So in the future, we also want to do some better integration of the monitoring system within our portal. So that means we want to also give the customer the opportunity to have some long-term overview of the data of his systems or of his services. We want to add some more application checks, specifically for HANA databases, S4 instances, and some old R3 systems. And also we want to extend the virtual router monitoring. That means we want to do it more dynamically, that we can also roll out new plugins and new checks to the existing virtual routers. So this is the plan for the future. And that's all from my side. Any questions left? Sorry? To the VR? This one?
So what's the green?
The green here. This is the guest network of the specific customer. So that one which is fenced through the virtual router.
And you have already added a virtual machine before that, right? The monitoring one.
Yeah, correct. So it takes some time before the synchronization script detects that there's a new router. So we have lag maybe about 5 minutes, depends on how fast the first customer VM gets deployed. And after this, the virtual router will be added to the monitoring configuration. To restrict what?
You guys give the customers the ability to restart the CloudStack network, or you guys have the auto detection for new VRs. What happens if the network is started?
What happens if the network isn't started? There is always a first VM deployed, which is our orchestration VM, which resides in the same network. So the virtual router is started when our orchestration VM gets deployed.
What happens if the CloudStack network is restarted quick? Does it detect if it's done by, how does it differentiate between networks down because the virtual router is being
That's a problem currently. So it can happen that we receive an error message, yes. So we maybe switch also later or to an event-based system and not a poll-based system every 5 minutes. But this is not implemented yet. But we have no that big amount of networks which will get destroyed and built up again. So it's more static in our landscape. Yeah. Other questions?
So the main aim of this particular slide is to add appropriate things to your monitoring VM so that you can monitor the VM.
Correct, yeah. Not just the VR, also the other customer systems. So we have one slave for every customer, so that we don't have problems with load on a central monitoring component.
At the end, this is a project in CloudStack, and each project gets such a monitoring slave. So, and if the script runs, you already have a running network with a running virtual router. And the API tells the script, okay, there is a new router. And then we go this way through the KVM hypervisor, install the agent, CheckMK agent, and then the script will configure the monitoring this new virtual router on this specific project.
What are you actually doing with the output that's monitoring? Is this being monitored in an off or something, and annual intervention afterwards, or have you got plans to maybe automate corrective action?
You mean some self-healing? Would be an idea, but maybe this is very risky for some cases. So currently we just receive alarms, and then we have to manually interact with the components which is affected. Yeah, but the idea was also there from our side. But I think you need a lot of testing to get this working really properly. Yeah, but the idea is quite good.
This HA feature of the KVM routers is maybe could work. With the old fashion, they have only one router, and then suddenly, whatever router gets destroyed, this is not working at all.
Okay, something else? Okay then, thank you.